Hi there, folks. Today we're looking at a little bit more data analysis, and we're just going to expand on some things that we've already done just a little bit. We're going to talk about two-way frequency tables, which are kind of an extension of the frequency tables that we've been doing. We're also going to talk about two more measurements of dispersion, which are variance and standard deviation. All right, and we're not going to get into great details about those. We're just going to use the formula a little bit and kind of talk about what those mean. You'll see a little bit more of those in your next course, and if you get into things like statistics and that kind of thing. So, two-way frequency tables. It's a table that shows the number of items in various categories, by dividing the categories across the top and down the sides of the table. And really, it's kind of an extension of the regular frequency table. We're still showing the number of things, but we're dividing it into different categories now. And that's why it's a two-way frequency table, because we're splitting it into categories. We're kind of showing the frequency from different perspectives, okay? For example, if I look at this guy, here's a two-way frequency table. And again, it's called a two-way frequency table not because we are showing only two categories or something like that. It's because we're labeling it in two different ways. See, before we only had labels across the top for our frequency table. Now we have labels across the top and down the side. So here's kind of the two-way. Instead of it going in one direction, see, we used to have labels just across the top. That was one way. But now we also have labels going down the side. So that's why it's called a two-way frequency table. All right. But again, it breaks this down into categories. We still have the totals, and you can kind of imagine what this would be if I was looking at it as just a frequency table. All right. I'd probably change the categories around, and I'd end up showing the math, science, and English, and just doing the totals with the frequency going across the top. Okay, but so this one, just reading the two-way frequency table, it says how many students are in Miss Bailey's home room prefer math, and so we have to identify Miss Bailey's homeroom, and for math, looks like she's got 8 students that prefer math. Okay, so the answer here is 8, and that's it. So we're just kind of reading this thing for now. All right. The second question says how many students overall this time, so overall prefer science. And really, if I didn't have that total category down here, I could look at this and say, oh, well, science, I have 6 from Miss Bailey's homeroom and 7 from Mr. Cole's homeroom, so it's a total of 13. But again, with the two-way frequency table, we typically include the total down here. So there's all of the science category added together. And that's kind of just how we read the two-way frequency table, okay? So it's broken down into categories. We have the total of each of those categories. And so when you look at this, you can even see the total number of students here is down here in the corner. And really, that's what the two-way frequency table always ends with. So not only do we have it broken down into categories, but we have the totals for each of those categories. And we could look at it differently. So we could look at the total of math, or the total of science, the total in English, or we could look at the total in Miss Bailey's homeroom, or the total number of students in Mr. Cole's homeroom. Okay? If I look at the next one, again, here's a two-way frequency table. The first question says, do more students live on campus or off campus? So again, I identify those categories, and I can go right to the total for those two categories. Here's on campus and off campus for the totals. And so it looks like off campus has more. So the answer to this question is off campus. And then it says, is it true that more women live off campus than on campus? So now we have to whittle this down a little bit more. So now we're just looking at women. Here's how many women live on campus, and here's how many live off campus. And so the numbers for on campus are higher, so this is not a true statement. More women live on campus, so we're going to say this one is false. Okay, but again, it's just reading these frequency tables and identifying the different components. Okay, so it's broken into a lot of different categories. You have to understand what each of those totals mean and where they come from. Okay. So now let's create one of these two-way frequency tables. So this one says there are 75 freshmen taking a foreign language. Of these, 88 take Spanish, 46 take French, and the rest take German. No one takes more than one language. There are 47 boys in Spanish, 31 girls in French, and 89 girls taking a language. And so we have to start to develop what categories we need. as we start to read this thing, it's only talking about freshmen. So freshmen is not one of our categories. They are a representation of the entire two-way frequency table. So keep that in mind. The freshmen are not part of the category. They're representing the entire table itself. So then we look at the foreign languages. We've got different categories in terms of the languages. So Spanish, French, German. So that's going to be maybe written across our top. All right. And then the separate categories that these things are broken down into are going to be boys and girls. So that's going to go along our side. So we have to start thinking about what the categories are. And so as I go to construct my table here, I've got the categories, and then I've got boys and girls and the total going along the side. I can give myself enough space. So again, we have one category over here of boys, girls, and of course we'll do the total. And then our other categories going across this thing would be the different languages. So we said Spanish. Maybe I should abbreviate here a little bit. French and German. And then, of course, we need to have a category for our totals. Okay? And so now I start breaking these things down. I just start filling in what I know. And keep in mind, the total of everything is going to be that 175. So that goes here. See, because that's talking about this entire table, and that will always end up in that total category down there. Okay? It's the total of all the boys and girls. It's also the total of all the students. All right? The foreign language students. And now we just start plugging these things into the appropriate category. It says 88 take Spanish. And again, that's the total number of students taking Spanish. That's not broken down by boys or girls, so that goes here. 46 take French. Again, that's referring to the total number that take French. And it says, and the rest take German. And the thing is, as you look at this, it doesn't give us the value for German, but because we know there's 175 students, we can take away the 80 and the 46 to figure out the number of German students. So when we do the 175 minus the 88 and the 46, I think we get a 41. And so then from there, we fill in that category, even though they didn't give that to us. We keep going. It says no one takes more than one language, so that's good to know. There are 42 boys in Spanish, so I can fill this guy in. Boys in Spanish is 42. It says there are 31 girls in French, so that's right here, French, 31. And then it says there are 89 girls taking a language. That's the total for the girls, goes right here at 89. Okay, and so you notice we've got a bunch of gaps kind of floating around, so we have to go category by category and see if we can fill in the gaps. And really, we need, when we look down any one of these columns or when we look across any one of these rows, we can only fill in the blank if there's only one blank. It's kind of like solving an equation. We can only have one variable. And so like right here, I can't fill in this top row right now because I only have one value and I have 3 blank spaces. So I don't have enough information to find that missing piece. Okay, so I need to find a column or a row that's only missing one piece. For example, if I look at the Spanish column, notice I'm only missing that one piece. And so if there's 88 total and there's 42 that are boys, then the rest have to be the girls. So that's got to be a 46. Okay, and see, so it allows us to fill in that piece. And now again, I look for another column or a row that's only missing one piece. Maybe I jump to the French next. And I say, oh, since I have 31 girls and 46 total, there has to be 15 boys. And so again, I'm still looking for categories that are only missing one. Maybe I'd go to like this row down here. So I've been pointing to those in green. I can't break from that tradition, right? So if I look at this row right here, again, because I'm only missing one, I have the total. I can subtract the 31 and the 46 and get 12. All right. And then from here, I can fill in this row. All right. Because once again, I only have one thing missing. I can do the 41 minus the 12 and get a 29 for this guy. All right. And now the only thing missing, and I can approach it from either this direction because I'm only missing one in that row, or from this direction, that column. Really, the smart thing to do would be approach it from each. So like if I did the 175 minus the 89, I get an 86. But then I can easily check this by doing the 42 plus the 15 plus the 29 to make sure it also gives me the 86, and it does. Okay, so I can kind of approach this from different directions to make sure everything works out. All right, but again, you essentially just fill in what you know. So it's about identifying the categories. We set up the table, we fill in what we know, and then we start filling in the gaps by looking for rows or columns that are only missing one piece. When only one piece is missing, we can jump in there and fill it in. Okay. The last thing we're going to look at is these extra measures of dispersion. We've got variance and standard deviation, and do not be intimidated by these equations, all right? I will give you these formulas on a test or a quiz. You do not have to memorize these. You just have to understand what they mean. And you'll notice that the variance and standard deviation equations are literally the same thing, except when you look at variance versus standard deviation, the only difference is I've taken the square root. So like imagine right here, if I were to take the square root of each side of this formula, here the square and the square root would cancel, and it would give me just this guy. And over here, and that's the symbol sigma, by the way, so I would get lowercase sigma. Over here, I would end up with the square root of that thing. Okay, so they're literally the same formula, but the standard deviation is one extra step of taking the square root, all right? And here's what this means. When you look at this, the x with the bar over it, we've mentioned this in a previous lesson, that the x with the bar over it is the mean. The x sub whatever, all right? So x sub n is each data value. So x sub 1, when we see this, is just whatever our first data value is. X sub 2 is whatever our second data value is. X sub 3 would be the next data value, and then the next data value. And that is basically the reason there's a dot, dot, dot in there is because we don't know how many data values they're going to be until we do an actual problem. So all it's saying is take the first data value minus the mean and square it. Then take the next data value minus the mean and square it. And then the next data value minus the mean and square it. And then the next data value minus the mean and square it. And the next data value minus the mean and square it until you run out of data values. Okay, which means we're done. All right. And then we divide by how many data values there are. That's the variance. And then to find the standard deviation, I take the square root. Okay. It looks complicated, but in practice is not very difficult. All right. For example, if I look at this guy, again, the first thing I need to do is find the mean. So that's going to require a calculator. So you grab your calculator and you punch it in. You add all these up and divide by how many you have. It looks like I've got 1, 2, 3, 4, 5, 6, 7. So I add them all up and divide by 7. And I believe when I do that, let's see. Oh, actually, let me just show it on the calculator itself. So again, remember, finding the mean is the average, where we add them all together and divide by how many we have. So I add them all up. I divide by 7, how many I have. So I get, looks like I have 14.57. I guess I'll go, you know what, I'll just go one decimal place, 14.6. Make life a little easier for myself, okay? So 14.6. And so now here's what the formula says. It says, let me scroll back up, take the first data value minus the mean and square it. So the first data value is a 10. So I take the 10 minus the mean, and then I square it. And then I add that to, well, then it says x sub 2. So it says, hey, take the next data value minus the mean and square it. Then it says, hey, you know what? Take the next data value minus the mean and square it. And then it says, you know what? Take the next data value minus the mean and square it. And then, you know, after that, maybe we'll take the next data value minus the mean and square it. And then perhaps after that, we'll take the next data value minus the mean and square it. And then I'll just keep going until I run out of data values. I take the last data value minus the mean. Yeah, that kind of fit, and square it, okay? And so again, tedious, yes. Difficult, no. And then I'll divide by how many data values I have, which is 7, okay? And then again, it's kind of a job for my calculator here. I'll break this down into steps. We could plug this in all in one shot, but you got to make sure you have all those parentheses there. So I would do 10 minus the 14.6, if I could type. Oh boy. Let me try again. 14.6. And then we want to square that. And again, when you square it, it's automatically going to kind of get rid of the negatives. So don't worry about negatives. So 21.16. And then we do the next guy. And then again, it's divided by 7. And so now, again, it's a job for my calculator. So I get a 5.96, it looks like. And that's my variance. The standard deviation then is all that same stuff, except I take the square root. So really all I have to do is take the square root of this last answer. So the square root of the 5.96. And it gives me 2.44. Okay? And here's what these measure. So you're probably looking at this like, okay, that was fantastic, but what in the world are we even doing right now? We're measuring how spread out the data is, okay? In other words, this guy right here, and we use the standard deviation more than the variance, okay? But the standard deviation kind of describes to us how far from the mean we have to travel to collect a certain amount of our data values, okay? So like when we travel 2.44 in each direction from the mean, from the middle values that we have, or the kind of the average value that we have, we will collect 68% of our data values. If I travel another 2.44 in each direction from the average, we'll collect a greater percent of our data values. And so kind of that's what this is describing. It's showing us how far we have to travel to gather our data values, which is showing us how spread out this is. If our variance or standard deviation, if our standard deviation is only like 0.5, we don't have to travel very far to start gathering up all our data values. But if the standard deviation is 100, it means I have to go really far to start gathering data values. It's just showing us the bigger this number is, the more spread out the data is. The smaller it is, the less spread out the data is. Okay.